China's latest AI breakthrough has leapfrogged the world.
I think we should take the development out of China very, very seriously.
A game-changing move that does not come from OpenAI, Google, or Meta.
There is a new model that has all of the valley buzzing,
But from a Chinese lab called DeepSeek.
It's opened a lot of eyes of like what is actually happening in AI in China.
What took Google and OpenAI years and hundreds of millions of dollars to build, DeepSeek says took it just 2 months and less than $6 million.
They have the best open source model, and all the American developers are building on that.
Now, DeepSeek looks and acts just like ChatGPT. OpenAI's moat may be shrinking if a model like DeepSeek can emerge with competitive performance, minimal cost, and reliance on existing outputs. It signals a rapidly shrinking barrier to entry in AI development, challenging the current dominance of industry leaders like OpenAI and Google and Anthropic and Meta, by the way.
Welcome everyone to our channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Pedro Magan. I have a PhD in computer science, and in this channel we talk about AI and machine learning and how we can make our life a lot easier with the help of AI. Recently, DeepSeek R1 model has been all over the news. Everybody's thinking how a model can achieve this level of accuracy with a fraction of cost. So in this video, I'm going to talk about the 4 steps that were required in order to make the R1 model. So this one, we are going to make it a lot easier to understand, so you can actually apply it to all of the other models that you have, and you can use it to fine-tune or develop the model for yourself. So we are going over the paper of this DeepSeek R1 model from a Chinese startup, and we're going to see what are the most important parts. As we mentioned, I'm going to break it down into 4 different components. As you can see in the beginning, they are actually showing the result. So the comparison of this actually showing that the model achieving an accuracy very similar to the ones with O1, which is the state-of-the-art model by OpenAI from a US company, and they're actually outperforming in many different applications, like for example math, and then they are also achieving this with a fraction of cost, and the parameter size of the models are actually reduced a lot. So let's take a look at what they have done in order to achieve this. So the first one that I want to talk about is using purely R. So the development of R1 actually started from R1.0 and then go over to R1. For the R1 model, they actually did not use any supervised fine-tuning or SFT, and they just go over the process of chain of thoughts. So what happened before was that they only use RL for basically preference alignment in after the post-training. So they want to make it closer to how a human would look like in terms of helpfulness, relevance, and so on. But right now, this is the first time that they have used an RL algorithm in order to training the process. And why is it important? Because for SFT, you require very high quality data, and it is not always available. And also an RL would help you to achieve some state-of-the-art model better than what you have already seen. But here we can see that the approach that they use for RL is basically a GRPO, or group relative policy optimization. So it's something between the PPO, or proximal policy optimization, and basic actor critic. So it kind of removed the need for the critic model, which was previously used for the preference alignment, and it actually required significantly less number of parameters in order to develop the model. Here we can see a very quick look at it. So it tried to have a policy old, which is the previous policy that we have. The policy is basically the one that is generating the tokens for us, and then there is a new policy, or pi theta, which is the one that is evolving over time. So they have samples. Instead of having one sample in proximal, they will try to have a group of samples. And then they obviously try to compute the basically the comparison between the previous the current policy and the previous one times the advantage function. And they obviously also try to clip it, kind of similar to the idea of proximal policy. And they also try to subtract it from KL divergence to the reference. So all of these will actually make sure that you don't diverge too much from the reference policy. And here we can see that how they compute the advantage is a little bit different. This This basically GRPO is another paper which was recently proposed, but then they basically pretty much use that one, and instead of just having an advantage over one, so you are going to compare on average between this group how this specific reward is better, and that's basically your computation of the advantage. And then another important part would be the reward modeling, because during the honor algorithm we need a reward function. So for the reward, what they do, they have tried accuracy reward and format reward. So this is the first RL. We will take a look at that inside the pipeline. They have another use of RL, but for the first one they only have accuracy reward and format reward, which is both rule based. And it is very important to note in here that the accuracy one is basically in case that there is a deterministic result. For example, it's a math problem, or it's a, for example, lead code problem. So there is for example, a compiler that run the code and give you the result whether it was true or not. So very accuracy based reward. And then the format reward, which basically they want to incentivize having a thought process, which is something that comes between the token of think. The reason that they didn't use a deep reward was basically they don't want the reward hacking to happen. First of all, it is hard to train a reward function because again you're gonna require some labels for that, and secondly the reward hacking, which basically it will try to generate some high reward while it has not basically pretty much learned anything, and this usually happens when your reward function is not complementary. They actually observe some intriguing phenomenon. For example, in a process during the think tag, they are trying to solve this problem and trying to find the real answers of it, and in the beginning, in the middle of it, they actually said that, oh wait, there is a moment and maybe I can solve it in another way. So they try to revalidate, and all of this actually happening on the basically the inference time. So this is actually the first time that we have seen this evaluation or re-evaluation through the finding results. So this actually looks very good, but there is one problem of it which actually lead us to the second point. Maybe we shouldn't just go all the way in RL. Maybe we should correlate. So now that leads us to the next point, the second contribution, which is basically the cold start. So the cold start idea is that they're gonna say, okay, we're not gonna don't do anything about self fine-tuning. We're gonna use some basically supervised fine-tuning, and we're gonna propose some chain of thought, but with a lot less number of data. You can just think it as a cold start. So you provide a baseline and then try to build on top of that how you're gonna work on your basically RL function. So pretty much it's like an initialization. You just initialize and it will help you with the readability, which basically means that you're gonna get some results that are more readable and understandable from a human perspective. So what they do on the R1 model was that, so they have a fine-tuned DeepSeek version 3 base, so their previous one, and they try to create some cold start data to it, and then they have applied the larger scale RL process into it that was developed in R10. So the one that I previously talked about, the R10, they instead of applying on completely fresh, they applied on the V3 base with the cold start data. So now what would be the purpose of this RL algorithm after this cold start is that they want to generate some samples. So basically the whole point in this second stage of the pipeline of generating the RL is basically generating some very valuable data that is used later on. So what they do is that they try to generate some samples. These samples are actually more human-aligned and more readable, and they're gonna use it to basically generate some samples when it achieved on the convergence side of the RL algorithm. Now on the third contribution, they have the rejection sampling, and that's very important when the supervised fine-tuning come again. So let's take a look at it. At first it was a cold start, which was SFT, then it was an RL to generate some sample, and then after that it's again SFT. So they try to the result from the checkpoints of the supervised fine-tuning, they're gonna use it in order to generate some role-playing, general purpose task, and so on. So you can see that in the very beginning the reward function that they have, if you remember, we said that it's only rule-based, but now they are moving into more complex tasks. It requires more complex reward function. So kind of seeing the process of basically curriculum learning. At the very beginning, you start from more easier, more tangible, and then later on you're going to some general purpose or role playing and so on. So the reasoning data from that is that they generate some reasoning trajectories and they try to apply the rejection samplings from it, which basically the idea that you can sample from distribution. So you create a proximal or proposal basically distribution and try to sample from it, and then you have a criteria to accept or reject it. So here they try to create some rule-based reward, and so they're gonna say that okay, what we do right now for this stage of the RL, they have the DeepSeek version 3 as the judgment, so they use an LLM as a judge in order to provide a reward for the generated trajectories or generated tokens for this specific task, because in that case they are doing some different task which cannot be done in with a simple reward. So they have collected 600k training samples, and they have the first one was a reasoning. For the reasoning they use LLM as a judge, so v3 version, and then some non-reasoning data, for example some factual Q&A, some self-cognition, the translation and so on, and then again they use this pipeline to reuse the portion of SFC. After this they have same as other approaches, they have basically idea like similar to other HF, so they try to do further alignment for that. So they want to make it more aligned with human preference. There's a secondary RL which improved the healthness, hardness, the 3H basically, and then the training model, the reward signal and diverse prompt distribution, and they basically do pretty much similar to R10. On the fourth and the last step of what they actually very focus on is basically the distillation. So distillation is not again very new, but they actually find something very interesting about it, which basically if we have a smaller model and we try to apply RL on it, compared to if we have a large model that has been already applied with RL and then we try to distill it to a smaller model, which one works better? And they actually look at this and understand that if they train on a larger model with RL and then distill it, you will receive a better result, which actually also kind of implies that the necessity for having a large model and large GPUs is actually again inevitable. Lastly, I want to very briefly talk about their unsuccessful attempts, which help us to understand from their mistakes, and also talk about the limitation and what's the future going to look like. So about the unsuccessful attempt, they mentioned that it's not necessarily going to be always bad. This is what they've didn't work for their case. So process reward model, so this is one approach that you can generate a reward. As we mentioned, they use a rule base that works perfectly fine for them, and then LLM as a judge, so process reward was not working for them. And then the other approach was Monte Carlo tree search. So this is also another approach inspired by AlphaGo, by OpenAI, which basically you try to have multiple basically run at the same time and try to go all the way to the end and try to see which of the branches are actually better, and then you select them. But the problem is that for the AlphaGo, the level or the number of possible actions were significantly lower compared to token selection. So token selection can actually pretty much explode after you have run, for example, like for example 5 step or 10 step into future. So it's kind of like impossible. So what they're going to work on in future is basically general capability. So it falls short, the R1 model compared to a V3 on some function calling, multi-turn or a complex role playing or JSON output. So these are very important for the AI agents, right? So function calling and JSON output are the ones that are frequently used. So they said that we're going to see that how chain of thought, how long chain of thought can actually help in terms of like AI agent pipelines that uses, for example, a specific function calling or a JSON output. The other thing is language mixing. So they use primarily on English and Chinese. So if you use another language, the chain of thought is going to be in Chinese or English or mixed. So they are thinking about how they can expand it to other languages. The other concept is about the prompt engineering, which is basically kind of similar to O1. So if you use a few shot examples, it actually performs worse compared to if you use zero shot. So for O1 model and also this R1 of DeepSeek, you basically need to be very clear of what you want to achieve, and you don't need to provide examples or few shots, otherwise it will deteriorate the performance. And there you have it, guys. We went over the DeepSeek R1 model and talk about the 4 steps and contribution that make it the state-of-the-art model in a fraction of cost. And if you enjoyed the video, make sure to like it, and more importantly, subscribe to the channel so you get more information like this. And if you want to see more video like this, make sure to watch this video that I created before, and I talk about the difference between prompting and fine-tuning. And also you can watch this video if you want to see the Llama stack, which basically is a pipeline generated by the group of Meta, and it to try to provide the AI agents for you very seamlessly. Thanks for watching, and see you until the next one.